And I'm Ryan.
And this is our game, Primes and Dragons. So if you ever played the iPhone game Puzzles and Dragons or Pad, you'll see many similarities with that in our game. In fact, it's a direct inspiration to our game.
So the main goal of our game is to eliminate the monsters on the top half of the screen, as you can see in this tutorial. To eliminate the monsters, you have to create a number that is divisible by the monster's assigned number in blue. So in this case, that number is 2.
So to create a number divisible by 2, you have to create a number that ends in an even number. So that's pretty easy. All you have to do is just make a number like this. It ends in a 6. So that's divisible by 2.
So the damage done to the monster is calculated by the sum of all the digits multiplied by a multiplier. The multiplier gets larger and larger as the number gets larger, therefore encouraging players to form bigger numbers.
After you clear all the monsters on one stage, you move on to the next. The stages will incrementally get harder, providing a challenge for the player. Once you reach the final stage, stage 50, you will be approached by a final boss, Miss Fraser.
And after you defeat Miss Fraser, once, she will transform into her final form!
So, she'll congratulate you and tell you that you have been secretly learning this whole time.
We used many control structures to perform many different tasks. We used if-else statements to determine what kind of stage to set up, and the corresponding text that will be displayed with it. Based on the integer stage number, which keeps track of the stage you're on, we call the appropriate method to form either an easy, medium, hard, or a boss stage, which in this case is located right here.
We also use many loops in our code. As shown in the method start game and here primesanddragons.java, we loop through the code 50 times. But however, if the player runs out of health, it'll stop the game. We also use not arrays but array lists in our Java code. So what an array list basically is that it's an array, but you can change the size. Normally arrays they have a fixed size, but in an array list you can add or remove units inside the array to make it bigger or smaller.
So in terms of data organization and management, we use over 70 image files, not including music and other sound effects. We utilize these images in methods such as getOrb, which is in board panel. We get the orb based on the specific number the variable str is assigned. For example, if we need to get an orb with the number 9 on it, the variable str becomes 09, and then we would be getting the file resources/sprites/orb/orb 09.png.
We create the enemies and the players in Primes and Dragons. So basically, we just have this object enemy, right? And inside the enemy, there's its prime number, its health, its damage, and and basically its name and its status. So we can use this to create enemies inside our stages. We put enemies inside an array list whenever we create a stage, but then whenever an enemy dies, we basically remove it so it disappears from the top of the screen.
So GUI was a pain. Basically, for all the animation, we had to use a swing timer to repaint the panel every microsecond or so. In order to start an animation, for example, the falling animation, we had to use a boolean that we would set to true. In this case, is falling. Then in action perform method, where the timer calls it every microsecond, if an if statement determines whether or not the orb animation for falling should be playing. If it is, we increment a falling orb onto every empty square below it. If there is an empty square on the top row, we generate a new orb right on top of it. This is where math and data types come into play. We use the math.random method taught in class to generate a random number from 1 to 10. Then we converted that into a string in order to access the image associated with the orb. Finally, we display it on screen and let it fall down. Once everything has fallen down and there are no more empty squares, we turn is falling to false, so that the animation won't keep on running while the timer is still running.
Originally, our game was far too hard for students. We had them make numbers divisible by 47 other random numbers, so it was completely way too hard to defeat enemies. We also added a fun and interactive tutorial in the beginning of our game to help the user learn the controls and add a little storyline to our game. Finally, at popular request, we added a final boss. Our educational goal was to teach middle schoolers how to about certain divisibility rules. Not only does the game teach that, but also reinforces and allows the student to practice their skills with our game. If a student is not very strong in their ability to find a number sense, we just have this serves as a great way for students to learn and reinforce their dank algebra skills.
Whoa, we did it! Yeah!